The discontinuities of a rational function come from the zeros of the denominator because we can't divide by zero. But there are two types of discontinuities, removable and non-removable. And they're very easy to remember because they are named very appropriately. Removable discontinuities is a discontinuity, so a zero in the denominator, that we can remove with some algebra. A non-removable discontinuity is a zero in the denominator that we can't remove with algebra. Let's see what I mean here. This is a rational function, right? It's a polynomial divided by another polynomial. It is not going to exist at x is equal to minus 2. Right? That's the one discontinuity of this function. You can't divide by 0, and when x is equal to minus 2, that's the 0 of that denominator. So is it removable or non-removable? Let's see if we can remove it with some algebra. The x plus 2 is already as simple as it can be. That's a single factor. But this quadratic in the numerator, I think we can break up into two factors. I think it's going to be x minus 3, x plus 2. Let's double check that. X squared minus x minus 6. Yep. Okay, so that's a good factorization. And now I can see that this 0 in my denominator, that x plus 2 factor, it actually does cancel. So this function r of x, if we simplify it, is really just the straight line x minus 3, except we have a removable discontinuity at minus 2, right? Because as the function is written, x cannot be minus 2. So in fact, this function, if we were to graph it, would look just like the line x minus 3. Except over here at minus 2, we have a open circle or a removable discontinuity. Let's look at this one. Again, we have another rational function. It's a polynomial 4th degree divided by a polynomial 2nd degree. And let's see if my discontinuities, which occur at minus 1 because of this factor, and it occurs at minus 10 because of this factor. Right, so these are x values that are not in the domain of my function. Those are my discontinuities. Let's see if we can remove any. That quadratic factor is going to break up as x minus 1, x plus 1. Double check me on that. And this quadratic factor, does that factor nicely over the integers? Yeah, we'll do x plus 2, x plus 3. Yep, that should do it. And double check me there as well. So we see that we do get some cancellation. This x plus 1 cancels with that x plus 1, but that's it. So one of these zeros of our denominator, one of these discontinuities was a removable discontinuity. The minus 1 was removable. The minus 10, though, was non-removable, right? We weren't able to remove that. So we were going to have a, over here at minus 1, if we were to graph this. So over here at minus 10, we would have a vertical asymptote. And over here at 1, we have a removable discontinuity.